This section is to find the equation of lines and the planes. And this section is complicated, it's harder than the previous sections. You need to really understand it to be able to solve the problem. So first, let's look at the equation of lines. To find the equation of line, we need to know two things. One is a point, P0. Okay, P0 is any point on the line. Will be qualified for this point. Okay, the P0. Okay, any point. So, how many lines we can have to through this point? Obviously, infinite many. Okay, so we need another condition. Another condition we're going to give is like a vector n. Okay, n is any vector your line parallel with. So if I give you those two conditions, n is a vector, okay, a, b, and c. If I give you those two conditions, obviously there's only one line pass through the point P0 and parallel with given vector n. Okay, now we want to describe any point uniquely determined by these two conditions. Okay, we'll pick any point, say P, with coordinate x, y, z. This point on this very thin line, so they must satisfy some equation. That's what we're looking for. Okay. If this point on the line, then we can make a vector from P to P, from P0 to P. We know how to find a vector from between 2 points. Okay. Using the endpoint coordinate, subtract starting point coordinate. Okay, if the point P on this line, then what we can say about those two vectors? One is P0, one is N. Obviously, they parallel, right? Okay. So any two vectors are parallel, they must have a relationship like this. One can be right, a scalar multiply another. Okay. So we write this thing. This means P0, P means x minus x naught, y minus y naught, z minus z naught. And T is a scalar, okay, times N is A, B, and C, which means scalar times vector means scalar times each component. Okay, we have two vectors are equal. That means corresponding component equal. Minus y0 equal to bt, z minus z0 equal to ct, which equivalent to say x equal to x naught plus at, y equal to y naught plus bt, z equal to z naught plus ct. This is what we call the parametric equation of line. What do we mean by that? For the given any t, you plug in there by knowing x naught, y naught, z naught, a, b, c. For given any t, you can find a point x, y, z. For the different t, you got a different point. Now, if you connect all those points, they will form this line you are looking for. Okay, so this is called parametric form. There's another form we called symmetric form, which look at it here. From the first equation, if you divide it by a, you got this equal to t, right? First equation, I divided a on both sides of equation, got this. Second equation, if you divided both sides by b, then you got a y minus a y0 over b. And also equal to t, so they're equal. And z minus z0 divided by c, and also give you t. That's why these three terms are equal, and we call this symmetric equation of the line. Okay, so to find the equation of line, you need to know two things. One is P naught, one is N. So it doesn't matter what kind of problem, you just focus on finding those two things. For example, I give you 2 points, P0, P1. I give you 2 points. So we know 2 points uniquely determine a line. Okay, how do you find the equation of that? So you can use any of those points as your P naught. Then we need to find the N. Okay, how do you find N? I give you 2 points, you can find a vector. Okay, obviously your line will parallel with this vector, right? So your N really is a P0, P1. So you have P naught and you have N. You plug in, you find your equation of line. Okay. I made another video for the equation of line and the planes because this section is hard. In the homework section, so here I only give one example. You can see more example in the video for homework. Find the equation of line and the planes. Okay, now let's look at example. We want to find equation of line through the point 2, 1, and 0 and perpendicular to both given vectors. One is I plus j, and another one is j plus k. Remember, to find the equation of line, you need to know P0, which is any point your line through with. So for this case, it's simple. They give you that 2, 1, and 0. And we need to find N. What is N? N is any vector your line parallel with. Remember that. Okay, now they said our line perpendicular to both I plus j, vector I plus j, and the vector j plus k. Okay. So our line parallel with that. Okay. So first of all, can you find a vector perpendicular to both given vectors? Okay. And we know that's exactly what the cross product does. Okay. So we can find a vector. Let's say I'll end there. We try this. Is this is a vector. Okay. Cross product another vector j plus k. What is a vector I plus j? It means if you write a triple, is a 1, 1, and a 0, right? And the other one is 0, 1, and a 1. Perform the cross product is I, j, k for the 1, 1, 0, 0, 1, 1. You will find a vector, say the first one is 1, the second one is also 1, if I did everything right. K there, second one is minus 1. The third one is 1. Okay. And I claim 1, negative 1, 1. This vector will be our N. Why? Okay. N is a vector. Your line, N is a vector perpendicular to both vector I plus j and j plus k. Okay, this n perpendicular to both of them because we perform the cross product, and obviously your line will parallel with this vector n. Therefore, n will be qualified to be the direction we're looking for. So your equation of the line will be x equal to x naught. What is it? Will be x naught will be 2 plus, this will be your a, b, and c. 1 times t, so it's t. Y is y naught, which is 1, minus t, z equal to 0 plus 1 times t, so it's a t. Okay. If you want to write a symmetric form, will be x minus 2 over 1 equal to y minus 1 over minus 1 and t and z minus 0, I don't have to write it, over 1. Okay, I said if you're looking for more examples, go to the homework, a video for homework. Okay. Now let's look at the equation of the plane. Okay, to find the equation of a plane, also we need two things. One is we're looking for equation of the plane. One is the point on the plane. We also call it P0. X naught, Y naught, Z naught. Okay. So you're talking about a plane. Then you have, well, at least we know one point on the plane. Okay. So how many planes we can make contain this point? Obviously infinite many. Okay. So we need more conditions. Now, if you give me another one, say give me a vector. This vector n there is, say, a, b, c. Vector n perpendicular to this plane. Okay. If you give me another vector, give me a vector, your plane perpendicular to this vector. Okay. We call such a vector normal vector. Okay. We call this a normal vector of the plane. Okay. Now, you give me two things. One is the point your plane contains. Give me a point on the plane. Another, you give me a vector your plane perpendicular with, which means normal vector. Okay. So how many plane can have a P0 on the point at the same time perpendicular to the given vector n? Obviously only one such plane. Okay, so one plane uniquely determined. Now we want to describe any point. We want to describe any point on the plane, say P, X, Y, and Z. If this point on the plane, they must satisfy some equation. Okay, because most of the point in the space they will not be on this plane. Okay, we're looking for the equation. Any point on the plane was satisfied. Okay. Now, P is any point on the plane, okay? So we can make a vector P0 to P, which is using endpoint, subtract starting point like before. Okay, if point P is on the plane, then this vector will be lie on the plane, right? Okay. So now what you can say about vector P0P and the vector n? Obviously they perpendicular each other, right? Because one vector is lying on the plane, another vector is perpendicular to plane. So they must be perpendicular to any vector lies on the plane. Okay, now we have two vectors that are perpendicular to each other. So that means what? That means dot product give you 0. So now let's perform the dot product, which means x minus x naught, y minus y naught, z minus z naught. That's the first vector, dot your normal vector, which is a, b, and c. They must equal to 0. What is dot product? Corresponding component multiply each other, then add them together. Dot product, remember, give you a scalar. Okay, for giving x naught, y naught, z naught, and a, b, c, then any x, y, z satisfy this equation, they will form this plane. This plane will have P0 on it and perpendicular to the normal vector n. So, just like find the equation of line, to find the equation of plane, you just need to know 6 things: x naught, y naught, z naught, and a, b, and c. Okay, what is a, b, c? A, b, c form a normal vector. Okay, now let's look at one example. We're looking for the plane, equation of the plane. This plane through the point -2, 8, and 10 perpendicular to the line x plus 1 plus t, y equal to 2t, z equal to 4 minus 3t. Okay, here's the problem. We have a plane. Okay, this plane contains point -2, 8, and 10, and perpendicular to a line. The equation of line has been given by this parametric form. Okay, now what we're looking for? To find the equation of line, a plane, we need to know P0, which will have that -2, 8, and 10. So we need to find the n, A, B, C. So how do we find the n? We know this plane perpendicular to the given line. Okay. So they give us equation of line. That means, okay, remember, for the equation of line, we have this sense. You always try to compare with the standard form. Z equal to Z0 plus CT. Okay. So for this line, my A there equal to what? 1, right? B is 2. C is -3. Okay. So vector 1, 2, and -3. What this means? For the equation of line, this ABC, this vector means what? A vector your line parallel with, right? Go back to the equation of line. So this means your line parallel with this vector. Okay. This vector, on the other hand, because this line perpendicular to your plane, therefore this vector will be perpendicular to your plane. Therefore, that's exactly what we're looking for. So we have our P0, we have our N, which means we have A, B, C. Therefore, we can write our equation of the plane immediately, which is A, this will be our A, B, and C. So 1 times x minus x naught, which is minus 2. So minus negative 2 give you plus 2. Plus b, which is 2 times y minus y naught, which is 8. Then minus 3 times z minus 10 equal to 0. That will be the equation of the plane we're looking for. So again, this section is hard. Okay, compare with the rest of sections in this chapter. This is more, you need to do a lot of thinking. It's not like you plug in things in the formula, you get it. Okay. So remember, find the equation of a line. You need to know two things. One is the point. One is the vector your line parallel with. As long as you know those 6 things, you can find your equation. Always concentrate on those. Doesn't matter what is the problem. Okay. For the equation of the plane, you need to find the two things too. One is the equation on the plane. Another is a normal vector you are plane parallel with. So for the different problem, you have to use all the conditions. Try to find those things. Once you find them, put it back in the equation, you are done. And also, please go to the homework video for homework. Look at more examples for the equation of line and planes.